Double inclined planes. Now here we are going to say case when all these two planes are rough. Previously we saw when one is smooth and one is rough. Now we are going to say when all are rough. Two rough planes inclined at 30 degrees and 60 to the horizontal. So just drawing this to the horizontal are pressed back to back. So back to back meaning they are connected. I mean they are meeting each other back to back, but this one is at 30 degrees and then this one is 60 degrees. So masses of 4 kilograms and 12 kilograms are pressed on the two planes and are connected. So if they start with 4 kilograms, so we're going to put here our 4 kilogram mass here. 4 kilograms. You follow that order which they are using to describe 4 kilograms and 12 kilograms. So this one is going to be 12 kilograms. They are placed there. Okay. On the two planes and are connected by a taut string passing over a pulley. So we have a pulley at this end here. So they are connected by a string passing over that. So we have a string is passing over this to connect to that. Of course, this one is in contact. Okay, so they are pressed and they are connected by that string there. Okay, so by over smooth pulley at the top of the plane as there is there. If the coefficient of friction is 0.5 on both, so meaning the roughness of these two is the same, so they are giving us the coefficient of friction as 0.5 on the same. Find the acceleration of the particle. So because this one is, of course, our acceleration is going to be in this direction, but if we move on to acceleration, it's not that this one is going to be having a weight. It is going to be 4 times gravity, and then we start by resolving that weight also. So this one is going to be 4g cos the angle 30 degrees, and then also this one is going to be 4g sine 30 degrees. Okay, after doing that also we come to this particle. It's going to be having also a weight which we get the mass times g. And then we are going to be having, remember this one is our 30 degrees, and this one now is going to be the 60 degrees. So this one is going to be 12g cos 60 degrees. Then this shall be having 12g sine 60 degrees. Resolving that weight, that's the best to start with. Okay, so after resolving that weight, we know that this is rough and this is rough. So we know that we are expecting some tension in these strings. I mean that string, but it's going to be the same because it's the same string. So we have T also there, also T in that direction. Okay. So now, because this one is bigger than this, we expect and not the resultant of these 12 newtons weights, and then this one, the resultant of a 4 newton is a 4 newtons weight. So that is what we do. Because the resultant here is going to be different from the resultant here because this one is having a different weight compared to this. So the resultant is different from this. Okay, so because we are going to expect our acceleration here to be in this direction. Because we expect this one, because this is 12 and this is 4, we expect it to be pulled in that direction. So that's where our acceleration is going to be, and this one is going to be pulled in that direction there. We always indicate the direction of acceleration. So if this one is moving, remember the planes are rough. So if this one is moved by this, the direction of the acceleration, friction is opposite it. So we are going to have our friction here. It's going to be mu, then the resultant R12 there. Then this one, because it's in that direction, then our friction is going to occur. This particle is going to be pulling this particle backwards, like this. So we are going to be having here mu. Remember, that's the roughness is the same, that's why I have mu and mu. But the resultants are going to be different. R4. So that is the basic. There, we had it to start with. Okay, so after doing that, then what's remaining is just and the questions. Okay. They want us to get the acceleration. First of all, we always start. Okay, let's start with the 4 kilogram mass. Remember, they are giving us mu as 0. They gave us mu as 0.5, the coefficient of friction there. Okay, so we start with now our 4 kilogram mass. In our 4 kilogram mass, you see, we start with the resultant. Once we have friction, we start with the resultant. So our resultant, because there's not any acceleration happening to the plane, means that this, they are in balance. So this is equal to this. So our R4 is going to be 4b cos 30 degrees. Now we take this to be 9.8. So our R4 is going to be 9.8 cos 30 is root 3 over 2. So my R4 from there is going to be, this is going to be 19.6 root 3 newtons. You can give it for the small presses, and this one is more accurate. Okay, so here we are resolving perpendicular to that plane. Okay, now if we resolve now, we see our acceleration is in that direction. So if we resolve in that direction, attention to the screen. So if I resolve now in the other direction, in this direction where our acceleration is going, remember, whenever we have acceleration, the force is equal to the mass times acceleration. This is the resultant force. So what is pulling it in that direction is that the degree for direction of the acceleration. So it's T. So the resultant is T, the resultant force minus, we have two opposing forces, this and then this. So we have minus 4b sine 30 degrees, then minus this mu R4 will be equal to our mass, which is 4, times the acceleration which we are looking for. You know, side that is a half. So T minus 4b into a half. Then minus mu, which was given as 0.5. And mu 0.5. Okay. And mu 0.5, which is the same as a half. A half into our R4, we got as 19.6 root 3 according to 4a. So this is going to be, when we simplify this, you see that this is going to be T equaling, okay, I want to make to the subject, so I take everything that I say. So T is going to be, this one is going to be 2 times, okay. This one is substituting, but when I substitute in here, I have 9.8 times 2, it's going to be 19.6. Then minus, when I simplify this, I'll be getting 9.8 root 3 equaling 4a. So, basically from there, if I take everything this side, okay, if I take everything this side, it's that 19 will be equaling to 4a, then plus 19.6 plus 9.8 root 3, and I call this equation 1. Now let us come to the 12 kilogram mass. We start by getting our resultant, so we resolve it. Sorry, there. The resultant is going to be there. So we are resolving that perpendicular to the plane. So in that direction, our R12 is going to be equal to this 12g, then cos 60 degrees. Our R12 will be 12 into 9.8. Then this is going to be a half. Our 12 is going to be, it's a half because cos 60 is a half. So there I have 6 times 9.8, which gives me 58.8, and these are going to be newtons. Okay, so after that, now we come to the direction of the acceleration. Our resultant force is equal to mass times acceleration. What is pulling it in this direction? Hope you can see. We have the 12 d sine 60 degrees, then minus, this is the only force which is going down, t which is opposing, then minus mu r 12 will be equal to the mass 12 times the acceleration. Okay, so we have everything. So we have here 12, 9.8 into, this one is going to be 3 over 2, then minus our t. We have our t there. We have our, okay, that's this. If we substitute there the t, here our t, we have it as 4a plus 19.6 plus 9.8 root 3, then minus our mu from here, our mu is a half into r 12, which is 58.8 equal to 12a. So from there, we just simplify. This is going to give us 6 times this. This is going to give us 6 times this. 58 58.8 root 3. Then minus 4a minus 19.6 minus 9.8 root 3 minus, when we get a half of that, we shall get 29.4 equal to 12a. So now, you see, when we simplify everything, so here I'm going to get this. When I take this side I'll be adding 16. So this side I have, first of all, this minus that. I have 58 minus 9.8 equaling to that. Then times proves to be. Then minus this. So here I'm having 35.8705 equaling to 2. When I take this side, I have 16a. The other side. So there, my a is going to be 35.87 divided by 16, which would be 2.242 meters per second. So that's going to be my acceleration there. After getting the acceleration, that was part A. This was our part A. Then our part B, they want us to get a tension. Where are we going to get our tension from? From here. So our T from 1 up from 1. Our T will be 4 into 2.242. Then plus 19.6. Then plus 9.8 out of 3. And so my tension will be so my tension is 45.542 newtons. So the question that order. So that's what we had to do in that question. I wish you, so here whenever you have this, you substitute it there. So this one is there. It's there. So that's what we had to substitute there. So that's it, members. I wish you well.